Welcome to this video lecture on the subject transmission lines and antennas. In this lecture, we are going to discuss about space wave propagation. Space wave propagation involves the transmission of electromagnetic waves in a straight line, primarily between line of sight transmitters and receivers. So, the characteristics of space wave propagation, it uses high frequency waves, microwaves, very high frequency, ultra high frequency, and above. They travel in a direct path from transmitter to receiver and usually unaffected by the obstacles like buildings or mountains. So frequency range for space wave propagation. So it typically operates at a frequencies above 30 MHz. So for example, very high frequency between 30 MHz to 300 MHz and ultra high frequency between 300 MHz to 3 GHz and super high frequency 3 GHz to 30 GHz and extremely high frequency 30 GHz to 300 GHz. So the common applications of this space wave propagation are TV broadcasting, radar systems, satellite communication and cellular networks. And factors affecting the space wave propagation. So line of sight requires direct visible path between the transmitter and receiver and height of the antenna. So increasing the antenna height improves the range. And obstacles. Buildings, mountains, trees can block or reflect the waves, leading to interference. And atmospheric conditions, rain, fog or temperature gradients can cause diffraction, reflection and absorption of the waves. Next, free space loss. In the absence of the obstacles, the power of the signal decreases with the square of the distance from the source. So, the initial power and distance from the transmitter ratio is taken to calculate the power at a distance d. And reflection, diffraction and scattering. So reflection occurs when the space wave encounters a smooth large surface, example buildings, and diffraction waves bend around obstacles like mountains or buildings, causing the reception in areas beyond the direct line of sight. And scattering occurs when the waves hit rough surfaces, causing the wave to spread in multiple directions. And types of space wave propagation. So line of sight, direct transmission from transmitter to receiver with no obstacles. And next is the tropospheric propagation. It involves bending of waves in the lower atmosphere, which is called as the troposphere, and it is significant for VHF, UHF and microwave frequencies. So next is the satellite communication. So space waves traveling through space to satellites and back to earth. And applications of space wave propagation. So first is the satellite communication. So it is used for communication with satellites for TV, radio and internet, and cellular networks, mobile phone communication using space waves in very high frequency and ultra high frequencies, and radar systems which are used for detecting the objects and measuring the distances using microwave frequencies, and radio broadcasting, FM radio and television signals. So let us see the applications of space wave propagation in detail. First is satellite communication. So space waves are extensively used in satellite communication, which involves sending the electromagnetic signals to satellites orbiting the earth and then back to the ground station. So it involves television broadcasting, internet services, global positioning system. So, direct to home satellite systems like Dish TV or cable services broadcast television signals from satellites to receivers on Earth. And satellite internet services like Starlink, HuxNet provide broadband internet to remote and underserved areas where terrestrial networks are not feasible. And global positioning satellites use space waves to transmit the location signals to receivers on the earth, providing accurate positioning data. So next is the mobile communication. So space waves are backbone of modern cellular communication. So where base stations, that is cell towers, transmit signals to mobile phones. So voice communication, data services, location services are provided. So mobile phone voice calls rely on the space wave propagation, especially for long range connection between the towers. And 4G, 5G and Wi-Fi networks utilize the space waves to provide mobile internet access with high-speed data transfer. And cellular networks use the triangulation based on space wave signals from nearby towers to provide GPS-like location services. Next is radio and television broadcasting. So it involves FM radio and television stations which use space wave propagation for transmitting the signals from broadcast towers to receivers. So space waves are used for terrestrial broadcasting where the signal is transmitted directly through the air without needing the satellites. So FM radio broadcasting and traditional television broadcast are used for this application. So let's summarize this topic. Space wave propagation is crucial for high frequency communication systems. So it works best in line of sight condition, but it is affected by factors like obstacles, atmospheric conditions and antenna height. So it is used in various technologies like satellite communication, radar and cellular networks. Let's take the assessment. What is the range of frequency at which the tropospheric scatter occurs? So it is option A UHF and microwave range. And tropospheric scattering occurs at answer is beyond the line of sight. So thank you for listening this lecture.